Welcome back, guys. So question number 7 of our book, in which we are asked to find the total impedance in polar form for the circuit which is given in 15.126. okay, so what is basically the circuit? Let me move down somehow. So this is the circuit, and in this circuit what we have to do, we have to find out first of all in part A the total impedance. Okay, so let me solve part A here. So in part A what I have to do, ZT is equal to the total resistance. So only resistance we have this R, so that is the R, and similarly here we have the inductor, so it has the inductive reactance with which I have to write the plus J, so that's why it will be plus J x of L. okay, so now writing their values, it will be 8 plus J6. so this is now in the rectangular. Now in order to convert it into the polar, what I have to do, let me use the calculator, and here 8 plus 6 iota. okay, so that is 8, and now in order to convert it into the polar form, what I have to do, I have to write it, and it will be 10, and the angle it has is 36.8, so 36.87, so 10 and the angle it has is 36.87 degrees, and that is basically in ohm. okay, we can also write ohm with it here, but I am writing it here because I have forgot it, and therefore written its angle here as well. okay, so that is the impedance. Now I have to draw the impedance diagram. So in order to draw the impedance diagram, let me draw it here. okay, so this is J, this is the positive axis, and what values will I have here? So R is 8 ohm, so 8 ohm is, let me, this is the 8, so this is 8 ohm, and similarly 6J. okay, so this is the x of L, and x of L is 6, so now it will be like, okay, so let me use this blue color. This is, what is this? This is 8 ohm resistor, this is the x of L, so now the value of resultant is this, and this is Z of t, and the value of Z of t is 10 ohm, while the angle it makes with it is basically 36.87 degrees. okay, so that is the impedance diagram. Now in part C, find the current I and the voltages VR, VL in phasor form. So in part C here, I have to find out the value of current. I have also found out the value of the total impedance. So therefore finding the current or the total current here is very easy, because this is the total current and the total impedance is also known. So that's why it will be E divided by Z of t. The value of E is known, and that is 100 volts with the angle of 0 degrees. So that is 100, and the angle it has is 0 degrees. Similarly, the Z of t is 10, and the angle it has is 36.87 degrees. Now it will be 100 divided by 10, and the angle it will have will be 0 degrees minus 36.87 degrees, so it will be 10 amps. okay, I have now written it correctly, and similarly the angle it will have is minus 36.87 degrees. Now this is the current. In order to find the V of R, let me represent them with this green color. So V of R is this current which is flowing through this resistor multiplied by the value of the resistance or the impedance it has. So the current which is flowing through it, as this is basically the series circuit, so from both of these elements the same current has been flowing, and that current is basically I. So therefore I multiplied by R, the value of I is 10, and the angle it has is minus 36.87 87 degrees. So okay, so multiplying it with the value of r, which is 8. Okay, so that would be 80, and the angle it has is minus 36.87 degrees. Okay, so that is in volts. This is V of R. Now in order to find the V of L, what I have to do, I have to multiply this with JXL, because now it has this value. So the value of I is again known, and that is 10 and minus 36.87 degrees multiplied by the x of L. The value of x of L is 6, but j is available with it, and I have told you that whenever you have any quantity with which j is included, or the imaginary quantity, what we have to do, we have to write the value which is the magnitude, and the angle with it is now 90 degrees. So now the values will be 6 multiplied by 10 is 60 volts. Okay, and the angle it has is 90 minus 36.87 degrees and plus 90 degrees. So how much would it be? 90 minus 36.87, and that is the 53.13 degrees. So as the it is plus here, so that would be 53.13 degrees. Okay, so that is the value of the voltage which is across the inductor. So this is part C, in which we have found out all the values which we have to find out. After it, what we have to do in part D of our question, what is it asking us to do? It is asking us to draw the phasor diagram of the voltages E, V R, V L and the current I. Okay, so in order to draw the phasor diagram, let me move down here. Okay, so now in order to draw it, what we have to do, this is part D. So here let me have this. Okay, so what is E? So E is this voltage. Let me represent is with this blue, all the voltage with this blue. So the first voltage is this T, and the angle with it is 0. So that's why this is 100, and let me represent it with this one and writing it like 100 volts. Okay, and this is E with the angle 0. Now I have to represent the value of VR here. So writing the value of VR, and the value of VR is 80 with the angle of minus 36.87 degrees. So as the angle is in minus, so that's why we will move clockwise from here. So it will be somehow here. So it will be like, okay, so this is the VR, and the value it has, amplitude it has is basically this is, let me call it amplitude it has is 80 volts. Okay, so this is V of R. This is V of R. Now after it, I have to represent the value of V of L. So the value of V of L is plus 53.13. So it will somehow lie here. Okay, so this is the magnitude it has is basically how much? 60 volts. Okay, and this is basically V of L. We have written it, and the angle it is making with this is positive 53.13. Okay, and the angle this VR is making is minus 36.87. okay. So that's why VL and V are 90 degrees apart from each other. So this is the phasor diagrams for the voltages, but now we also have to draw the current here as well. So for drawing current, let me use this green color, and the current here is basically 10 amps and the angle with it is 36.87. so that is this one. Let me write it like this. okay. So this is what this is the current. okay. So in the resistor you may very easily see that the current is in phase with the voltage. So in the resistor current and voltages are in phase, and you may very easily see from here, but in the inductor you can see that the voltage is now here while the current is now 90 degrees away from it. And similarly we can also see that here the voltage is leading because it has achieved the positive angle as compared of that of the current. So that's why in these type of circuits where the inductor the impedance wherein the impedance the inductive element is dominant, so these are basically the inductive circuits where the voltage leads while current lags. okay. So similarly as you will see that we will also find out the value of the power factor as well. So as the current is lagging here, so therefore power factor will also lag here, okay, because the power factor of any circuit will be related to the current. Whether the current is lagging or leading, the power factor will also be lagging or leading in that circuit as well. okay. So that is the phasor diagram of this circuit. Now moving forward here, so we will see that in part E of our question what we have to do, we have to verify Kirchhoff's law voltage across the closed loop. okay. So according to the Kirchhoff's law, let me write it here. So according to the Kirchhoff law, E is equal to the VR plus VL. okay. What is the value of VR? So the value of VR is already known, and that is 80 minus 36.87 degrees, and the value of V of L is how much? That is 60, and the angle it has is 53.13 degrees. okay. So now in order to do it, what we have to do, let me add them together. So if you are doing it manually, you may basically proceed by using two methods. In first method, you first have to convert these quantities into the rectangular form, then perform the addition here, because for the rectangular quantities addition and subtraction is the most feasible operation to perform, and after it, once the real and imaginary components has been obtained, you may convert back into the polar form. But in order to use the calculator and for our own convenience, we are going to use our quantities here in this calculator, and the same quantities will be used. So writing here 80, and the angle it has is the minus 36.87, and similarly adding it with the 60, and the angle it has again 53.13. okay. So now adding them together, what will you get? You will get somehow like this one, and that is almost, how much is it? That is 100, and the angle with it is almost 0 degrees. So that is the value of the voltage, which we may see that is also here. So this implies that the KVL is validated okay, and the Kirchhoff's voltage law has been proved. Okay, so this is the solution of part E. Similarly, find the average power delivered to the circuit. So in order to find the average power here, let me, what I have to do, this is P and P is the average power. So EI, and as that is the average power which contains only the real power, so that is why I also have to encounter the angle between the voltage and current, writing their values. So voltage is 100, the current is how much? The current is 10 with the angle of minus 36.87, 10, and cos of minus 36.87, which is as that of the positive one. So writing it here, I will get here 1000 and multiplied by the cos of 36.87. so using it, sorry, 1000 multiplied by cos of 36.87, and what I will get here, let me write the negative sign here as well in order to reduce any confusion. So it is now 799.99, which is almost 800. So 800 watt is the power which is the average power. Okay, and now this quantity here, this is the power factor here. So power factor, what is basically the power factor? Power factor is the cos theta, or you can also see that power factor is the value of the real resistance out of the total impedance. Okay, so the ratio of the resistance with the total impedance is basically the power factor, and you may calculate it from this one. So in order to find the average power, you have to multiply with it the power factor as well, which shows you how much energy or how much resistive element is already available in our total impedance. Okay, so that is part F. So after part F, we have to find the power factor of the sector, indicate whether it is leading or lagging. So again, as we have already found out that, let me call it G. So I have told you that that is cos of theta. So cos of the theta of which the voltage and the total current has. So cos of minus 36.87 degrees. Okay, so let me calculate it. Cos of minus 37.87. So how much is it? That is almost 0.8. Okay, so as the circuit here we have is the inductive, and I have told you that in any inductive circuit the current lags. So therefore this power factor is lagging power factor. Apart from it, as I have told you that power factor is always also equal to the R divided by Z of t. Okay, so the value of R which we have seen here is basically 8 here, because you may see here from this circuit the resistance is 8 ohm, and the value of the total impedance we have calculated, the magnitude it has is basically 10 ohm. Okay, so now writing it here, I will get this 10, and from it I will again get this 0.8, and due to the nature of the circuit, that is lagging. Okay, so from these two methods we can calculate the power factor here. Okay, similarly in part H of our question, we are asked to find the sinusoidal expression for the voltages and currents if the frequency is 60 hertz. So I am going to write the sinusoidal expressions for the E, VR and V of L. So for writing them, what I have to do, that is part H, and here the frequency is 60 hertz. Okay, so therefore the angular frequency will be 2 pi f. Okay, writing their values, so 2 pi 60 and that would be 120 pi radian per second. So that is the frequency. In order to find the value of the total voltage here, so the value of the total voltage here was 100 and 0 degrees, where this voltage is basically the RMS value while this is the phase angle. So therefore in order to write them in the form of the sinusoidal wave, what I have to do, I should have the peak values. So converting the RMS value into the peak values, what I have to do, I have to multiply with a square root of 2 and that is the RMS value it has, and after it the sine of omega t plus theta. So omega is already known and that is 120 pi of t and the angle it has is 0 degrees. So that's it. Similarly, the value of V of r, the value of V of r was how much? So the value of V of r was 80 minus 36.87. So the same procedure here, 80 minus 36.87. So the same procedure here, same rule here, 2 multiplied by 80 and sine of 120 pi t and the angle it has is 36.87 degrees. Similarly, V of L, the value of V of L was how much? Let me see here, that was 60 volts and the angle with it was 53.13. So writing it here, 60 volt 53.13 degrees. So the same procedure here, square root of 2, 60 and sine of 120 pi t and the angle is 53.13 degrees. Okay, so this is about all the voltages. Similarly, in order to convert the current into the sinusoidal form, what I have to do, I have to write the value of current. So the value of current is how much? I have calculated it here as well and that is 10 amperes minus 36.87 degrees. 10 amperes and minus 36.87 degrees. Okay, now the same rule which we have seen here, that is square root of 2 multiplied by 10 and that is sine of 120 pi t and the phase angle it has is 36.87 degrees. Okay, so that is for the current. Here we have seen the current in the phasor form and here the sinusoidal form as well. Okay, so what is the last part? So in last part of it, I have to plot the waveforms for the voltage and currents on the same axis. So again I have to plot these values over the same axis. So let me represent this voltage with this red color, this V of r with blue color, this with the green color and the last one here, this current with the black color. Okay, so let me plot it here. Let me have it here. This is, let me call time axis. So first of all, let me plot the voltage here. So for plotting the voltage, the angle is 0 degrees, phase angle is 0 degrees. So it is now very easy for me to plot them. Okay, so that is the value of the voltage. So the peak value it has is this square root of 2 and 100 and this is the negative peak value which is minus square root of 100. Okay, so now after it we have V of r, the angle it has is minus 36.87. so that's why this is representation with this one, this 36 somehow lie here. Okay, and as this one is basically the negative one, so 360 degrees minus 36.87 is almost I think 3 23.2 something. Okay, so that is somehow here. Okay, so that's why this will start from here. Okay, so phase angle is here and it will start from here, so this will be like this one. Okay, so this will be like this one. So this is phase it has, and the amplitude it will have will be square root of 2 into 80s. Okay, so that is for the V of R. Similarly, for V of L, the angle is 53.13 degrees, and I am going to represent it with this one. So 53.13 degrees lies somehow here. Okay, this is the 90 degree, this is 45, so it almost lie here. So let me write it like this one. So this is will be like this one. Okay, so I think it here I have made some mistake. So here it will be, you may grasp that how it would look like, such that these two will be 90 degrees apart from each other. So that is what this is V of L, this is V of R. Okay, so these are the voltages, and the amplitude it has is basically this one. Sorry, with this green. Okay, so that is the amplitude. Now the last one here is the current, which is in phase with the voltage across resistor here. So again, now this is this one, so again this will be like, now it will be like this one, because this one will be like this. Okay, so that is the value of the current here. And the waveforms here are not that much clear here, but the amplitude it has is square root of 2 into 10, while the angle it has is 36.87 as that of the current. So the waveforms here are not that much clear, but you have seen all the concept behind the voltages plotting and the phase angles along with them. Okay, so that's it for today, in which we have seen the analysis of a simple series RL circuit, and phasor diagrams, power factors, and many other concepts have been cleared here. So I think it's enough for today, and I will see you with some more question in our upcoming videos. Thank you so much.